So now that we've talked about the server structure, functionality, and implementation, it's time to turn our attention to the client side. You'll see there's some really interesting things on the client side that are worth considering. And that's, of course, what's sending the requests asynchronously from the test driver over to the server. So a couple things. We have a class that's going to provide the mechanisms for making these calls. And as you can see here, it's called PCClient Parallel Flux. And we've got one for the concurrent flux stuff as well. And in this particular class, it's going to define several things. This is a component, a Spring component, so we can do auto wiring where we need to, like here, where we're auto wiring the PCClient Parallel Flux to the PC Proxy API. So the PC Proxy API, as you might expect, is going to be using Spring's mechanism for being able to do declarative type-safe client proxies. And we'll look at that in a bit more detail. You need to know how to do that for your assignment 2C and 3. Here's the test individual calls method. That's going to send the calls to the receiver one at a time, but concurrently. So that's pretty cool. And let's go ahead and take a look and see how that works. So we'll go through this in more detail, but this actually looks quite a bit like the server-side implementation, except it's on the client side this time. And so what it's doing is it's using a parallel flux. So it's taking the flux and it's turning into a parallel flux, running it on a different schedule. We'll talk about why we do that in a second. Then it's going ahead and sending it to the client and getting the results back. Notice in this particular example, parallelism is performed by the client rather than the server. The server is getting the request, and the server is actually running in parallel too, but we only have one item coming in at a time. So the server is not processing the prime checking in parallel, but many calls that come in will run in parallel. We use a bounded elastic scheduler for this case. The reason we do that, and we don't use the parallel scheduler, is the parallel scheduler only handles CPU-intensive tasks. It doesn't handle I/O-intensive tasks. And making a call to the server is an I/O call. It's going to call the network. So if you were to replace if you were to replace bounded elastic with parallel, this code would fail. And you'd get a very strange error message rather than using the bounded elastic call. So we want to use bounded elastic because that allows this call to block, which it's going to do. But we want it to block in the right context. We don't want it to block the calling thread. This is actually the call that sends the request to the server, and you can see it's basically calling through the proxy, passing in the strategy and the prime candidate. So we'll look at that code a bit more in a second. Here's the test flux call. This is the one that sends it all in one fell swoop as a flux of prime candidates. And you'll notice that this sends it as a post request, not a get request. This call here, over here, is going to send things as a get request. This call here, which we'll see in a second, sends it as a post request. The reason why that's the case is that we're actually sending this stuff here as a flux, so we need to make sure that that goes in the body of the HTTP request. That's why we're sending this as a post. So here's what the implementation looks like. It's really simple. We take the prime candidates flux, and we simply go ahead and say check if prime flux, saying what strategy we're using, and we pass the flux in, and that sends the thing over in one fell swoop via the application ND JSON value media type, and that'll stream it over to the server. Any parallelism that's performed is performed by the server, not by the client. So let's talk about the PC Proxy API stuff, because that's also important to understand. And the nice thing about this is this is all generated for us automatically. So you can see we have two proxy methods. These are the ones that we're calling from the client code, shielding all the details of having to do remote method invocation using good old HTTP. This is a little different. I think we talked about this before. Unlike the controller side, where you have a get mapping and a post mapping, here we have a get exchange and a post exchange. Don't forget that, because you'll get weird error messages otherwise. And these are, of course, the ways we route to the endpoint handlers in the controller. And then this is the thing we have to put on the client side. So remember, on the server side, we had to mark the check if prime endpoint handler method as being consuming the application ND JSON value. On the client side, using Spring 6 HTTP interface, you have to say this is going to use the content type application ND JSON value. At least this piece here, the application ND JSON value, is the same, whereas the name is a little different. So this is content type on the client, but consumes in the server. And if you don't do this, again, you can't send this parameter as a flux. These annotations are also required, and they indicate how to send the data. So you'll see here we have request param for the strategy and the prime candidate for check if prime, and then down here, check if prime flux. The request param is used for the strategy. That's going to go in the URL, whereas request body will go in the actual implementation of it'll go in the body of the HTTP post request. And you can see here that we return a flux. So that's another cool thing you can do with HTTP interface in Spring 6 is you can return reactive types and you can pass reactive types. OK, so that's kind of the end of the overview of the structure and functionality of the client.